Hey guys, and welcome to this new class on this course on aerospace engineering, aircraft systems and avionics. Today we will present what the hydraulic system is, and we will start by studying the basics. Right, so the hydraulic system is a transmission system that uses pressurized hydraulic fluid, commonly a type of liquid, to act on hydraulic machinery. That is machinery that is based on the actuation of some hydraulic system. Okay, so the main idea for hydraulic system is that we need to provide some amount of pressure, right? And we do that by actually using a generator. Then we need to orient or to distribute this pressure or this fluid in one direction or another direction, which is basically using a driver or a valve controller. Okay. And finally, we have what would be the actuator, which is essentially what we are actually moving, okay? The hydraulic machinery. That is, for instance, providing movement to the flaps or either to retracting the landing gear, okay? Right, so the hydraulic system is actually based on what is known as the Pascal's Principle. And that is, the main idea of the Pascal's Principle is that by applying a relatively small force, we are actually able to move objects which require a lot of force, okay? So essentially we would be able to move, by moving this piston over here, we would be able to actually move a whole entire car, okay? And this is the main idea of the hydraulic system and why it's essential in aircraft technology, but also in many other technologies today. Right. So the main idea here is that we have this kind of U-tube, okay, over here, which is connected by this fluid, okay, which you can see in gray. Right, so as you probably know, a fluid has a relation to pressure, okay, meaning that any fluid that you know will be related to some amount of pressure. And this amount of pressure is, of course, exactly the same throughout all the fluid, right? So again, the meaning here is that by applying a certain amount of force, we would actually be providing or applying a certain amount of pressure to the fluid. And by applying another force, okay, over here, we would actually be providing another pressure to the fluid over here. And as you can see, there's a certain continuum, okay? So basically, we have a pressure over here and a pressure over here. Right. A hydraulic fluid is connecting two pistons, this one and this one, and due to the continuity of the fluid we will have an homogeneous pressure. What does this mean? That fact that even if we here see that this is pressure 1 and pressure 2, we need to establish, because of the continuity of the fluid, that all the pressure throughout the fluid will actually be the same, meaning that pressure 1 and pressure 2 will be the same. And this is what is known as Pascal's Principle. Why is this important? Well, the fact is that the pressure is actually the relation between the force and the area it acts on, okay? Meaning that this force divided by this area, suppose that this is cylindrical, okay, is equal to this amount of pressure. And this amount of pressure is actually equal to this amount of force, which is the weight of the car in this case, divided by the area. So as you can easily derive, pressure 1 and pressure 2 are the same, as stated before. So force 1 divided by the area 1 is equal, okay, to force 2 divided by area 2. Now, the idea here is that we can actually, lift the car with a tiny force if the area ratio is high enough, okay? Meaning that the relation between the force 2, which is the weight of the car, and force 1, which is the pressure or the force that we would be applying on this piston over here, is actually nothing else than the relation between the areas, right? So as you can see, imagine the car weighs, let's assume 1,000 kilograms, okay? And the force that we apply is 1 kilogram. Then by simply deriving the ratio between areas, we can see that if this is 1 squared meter, or let's put like 1 squared centimeter, okay, we would actually need 1,000 squared centimeters over here as to provide 1 kilogram of force over here, and be able to lift a car which is 1000 kilograms over here. And this is actually very important in aircraft, meaning that if the pilot does a relatively small force, we can actually be able to move big components on the aircraft through this kind of transmission, okay, using hydraulic system. Right, so again, well, I just wanted to remark this idea by having this bit of an example. The idea is that traditionally in aircraft, especially in the beginning, there was no transmission due to hydraulic systems, okay? The pilot would directly imply, it would make a force, and that force would provide actually the movement on the aircraft tail, for instance, on the different control surfaces on the tail, okay, or the ailerons on the wings. However, nowadays, as you can imagine, especially on the case of the Airbus A380, you can simply say, okay, there's no way that the pilot will be able to make that kind of effort in order to move the flaps, for instance, of the aircraft. Therefore, it's absolutely essential to have good hydraulic systems and, to make sure that this system is reliable and functions correctly throughout the flight, okay? So with this, we can go to the next class.